Welcome you all to the video lecture on design concepts and principles. Let's move on to the topic. Characteristics of good design. A good design must implement all of the explicit requirements contained in the analysis model and the implicit requirements which is decided by the customer. It must be in a readable and understandable guide for those who generate the code and those who test and those who support the software. The design should provide a complete picture of the software so that it will be easy to build by the developer. Software design concepts. It provides the necessary framework for implementing the right software. The various issues that is to be considered while designing a software are abstraction, modularity, architecture, refinement, pattern, information hiding, functional independence, refactoring, design classes. Principles of software design. These are the following principles. The design process should not suffer from tunnel vision. That is, the design must cover a wide area rather than narrowing the requirement. The design should be traceable to the analysis model. The design should not reinvent the wheel. The design should minimize the intellectual distance between the software and the problem as it exists in the real world. The design should exhibit uniformity and integration. The design should be structured to accommodate the changes in the future. It should be structured in a way that if any abnormal data or events or operation conditions are encountered, it must degrade gently rather than stopping abruptly. Design is not the coding and coding is not the design. Design should be assessed for quality when it has been created and not after the fact. The design should be reviewed to minimize the conceptual. It is coupling. It is a measure of interconnection among modules in the software structure. There are various types of coupling: data coupling, control coupling, common coupling, content coupling. In data coupling, the modules passes the parameter or does the data interaction among themselves. The next is the control coupling. Here the module share the related control data. The next is the common coupling, where the data or the global data is shared among the modules. The last one is the content coupling. It occurs when one module makes the use of data or control information which is maintained in the other module. Abstraction is an ability to cope up with the complexity. The software design occurs at different level of abstraction. At high level, the solution must be stated in a broad terms. And in lower level, more detailed descriptions of the solution is to be given. In the procedural abstraction is a named sequence of instruction that has a specific and limited function, whereas in data abstraction it is a named collection of data that describes the data object. Refinement. Refinement is actually a process of elaboration. It is a stepwise refinement, that is, it is a top-down design strategy. We begin with a statement of a function that is defined as a high level of abstraction. That is, a function's description alone is given at the initial stage. The refinement causes the designer to elaborate the original statement, providing more and more detail as each successive refinement occurs. This is called as elaboration. Abstraction and refinement are complementary concepts. In abstraction, the designer enables to specify the procedure and the data. It suppresses all the low level details. Whereas in refinement, all the lower level details of the design are provided as the progress goes on. So in abstraction, the details are not specified in a very detailed manner, whereas in refinement, a lower level or in-depth detail of each and every information is given. So both the concepts helps a designer in create a complete design model as the design involves. Cohesion. We can hide the information by using the cohesion. Cohesion can be represented as a spectrum. The scale of cohesion is nonlinear. There are various types of cohesion. Coincidentally cohesive. Here, the modules that performs a set of tasks are related to each other loosely. Logically cohesive. Here, the module that performs the task are logically related. The next is the temporal cohesion. Here, all the tasks must be executed with a small span of time. The next is procedural cohesive. That is, when the processing elements of a modules are related with one another and must be executed in some specific order, then such module is a procedural cohesive. The last one is a communicational cohesive. When the processing element of the module share the data, then such a module is called as communicational cohesive. Activities involved in interface design. It establishes the goals and intentions for each task. It maps each goal and intention to a sequence of specific actions. It specifies the action sequence of tasks and subtasks. And indicates the state of the system, that is, what does the interface look like at the time that the user scenario is performed. Defines the control mechanism and it shows how the control mechanism affects the state of the system. It indicates how the user interprets the state of the system from information provided through the interface.